Hey legends, welcome to the Homework Helper. We only have about 6 weeks to go, so really important we're getting in and getting our review, for our end of year, particularly if you want to start prepping for the regions, which you have the option to take. Alright, so the first part again is your notes from the week, so summarizing a few of the key things. When dilating a segment, what happens to the length of the original segment? So we have to look at the scale factors in this case. If the scale factor is less than 1, so if the scale factor is less than 1, what that means is the shape is actually going to get smaller. The segment will decrease in size. But if it was larger than 1, it's going to get bigger. You might be thinking, what happens if it is 1? If you multiply something by 1, it just stays the same size. Alright, our second thing here, explain why lengths cannot change when dilating a line. Lengths cannot change as lines are infinite. So we put the arrows at the end of it. Lines are infinite in length. Alright, let's take a look at some of the problems we should be able to solve given these little skills. Alright, so I'm going to go through and start to underline things that are important in our question. So line L has the equation y equals 5x minus 5. Write the equation of the image after a dilation, the scale factor 1/5, centered at the origin. So that's what we're doing, we're writing the equation. So we all know by now if we dilate a line or a segment, it's always going to be parallel, which means our slope is not going to change. So straight away I can write down y is equal to 5x. Now the little trick when we are when we're dilating from the origin is the only thing that's going to change is this part on here, the y-intercept. And all that happens to it is it multiplies by the scale factor. So what I mean by that, our scale factor of 1/5, 5 times 1 over 5. What that actually does is the 5 times is by the 1 on top. And we get 5 over 5, which equals 1. So y is equal to 5x minus 1. It gets 1/5 of the size, or I share it amongst 5 people, and I get 1 share. Let's take a look at the next one then. So similar sort of situation. A line has the equation of negative 1/4 x minus 3. Write the equation after a dilation with a scale factor of 2, centered at the origin. Alright, so again what we're going to do here is we're going to write the equation. Alright, so when I start to put that in, again the slope won't change. So we're going to get y is equal to negative 1/4 x. And all we have to do is actually look at the y-intercept, and we're going to multiply it, negative 3 times 2. Alright, so all that happens there, negative 3 times 2 becomes negative 6, and we have our answer. Alright, changing over to another skill we've been refreshing this week, we're looking at finding the coordinates of point P. So that's what we're trying to find, that lies along the directed line segment from M to N and partitions the segment 3 to 2. Alright, so 3 to 2 is great if we're breaking up something that is 5 parts in length. Like when you're mixing Kool-Aid or baking, you get those ratios. Alright, so 3 and 2 together make 5 parts in whole. So what we're going to do is, the diagonal is really hard to break up, so we're going to split it into 2 straight segments. I'm just going to count the squares here. So I've set up a right triangle. Wouldn't have mattered if you went that way. You would still get the same thing. Oops, don't know how that happened. Alright, so you'd still get the same thing. So what we're going to do then is count them. We've got a 5, and we've got 1, 2, 3, 4, 5, 6, 7. Now I can see here the 5 on the right hand side, well that's already 5 in total, just like our ratio. So it's the one that I'm going to break up at a ratio of 3 to 2. Now it asks us to break it up M to N. So that means the side that's touching M is going to get 3, and the side that's touching n is going to get 2. Alright, so what I do here, I'm at m at the moment. I want to break up this 5 over here. So what I'm going to do is I'm going to go, so I'm in line with the m, and I'm going to give this side 1, 2, 3, and I'm going to split it right there. We can see now I've got 3 squares here that I'm colouring in below the mark. Above it, I have 2 left over. That's where my 3 to 2 comes from. Okay, so I've broken up that 5, a ratio of 3 to 2, and all I do, where I drew my little barrier there, I just draw it along until I get to the segment, and there's my point there at 1, 0. Alright, that's my coordinates of my point. Okay, the one below it is a little bit harder. We still need to do the same setup. Alright, so I'm still going to set up my right triangle. Map below shows straight highways between the towns of Ashford and Bedford. I'm going to cross all that out. It's not telling me anything I need to do on a coordinate plane. Highway planners want to build 2 rest stops between the 2 towns. Okay, so that the 2 rest stops divide the highway into 3 equal parts. So if we're getting 3 equal parts, what we're actually building is 1 to 1 to 1. So a ratio you haven't seen before. 3 equal parts. Alright, so let's take a look at our side lengths. We've got a side length of 1, 2, 3, 4, 5. Oops, 5 on this side, and 1, 2, 3, 4, 5, 6 on this side. So now I'm at a point where I've got to change my ratio. Okay, this is really great for 3, but I want to see what 3 goes into. Now 3 doesn't go into 5. I can't multiply it easily and make it 5. So what I'm going to do is I want to change it so it equals 6, which means I'm going to times them all by 2. Alright, so it keeps our ratio the same, but it's just no longer a simplified version. So if I go 2 to 2 to 2, that would give me 6 in total. Alright, so we're going to break this up so each part gets 2. There's my first mark, second mark, so now I've got 2, 2, and 2. So like last time, all we do is we go up from where our barriers are until we hit our line. Now we've broken up the line between Ashton and Bedford into 3 equal segments. Okay, back into the similarity stuff. So what we do with similarity is we check between our 3 rules. All right, so if we want to determine if they're similar, first thing we always check is angle, angle, because it's the easiest. Okay, remember that's 2 angles from each triangle. It's the easiest because we don't need to do any math. The second one, side, angle, side. And then our hardest one, side, side, side. Okay, they're harder because we have to check the proportions. Alright, so in this one we want to see if the big triangle HGF is similar to the little triangle. Everyone's been really, really good at redrawing these, so I'm going to redraw them. Okay, there's my HGF and my little triangle HUV. Now straight away I can't do angle, angle, okay, because I don't have 2 angles anywhere. But what I do have, they both have angle H in them. Alright, so I'm going to put that straight in there, and this is the one we're going to try. We're going to try for side, angle, side. Okay, so I'm going to put similar side, angle, side here to see what we're trying. Now let's add our numbers on. So G to H, 65, and H to F, 50, and we don't know our missing side here. Alright, so I need to get, now I can see VH is already 40, but I need this other matching side. So I can see the whole length is 65, but this bit here is 13. So what I'm going to do is I'm actually going to take the 13 away, so I know what's left here, okay, which means I'm going to get 52. Alright, now I need to check these are actually in proportion. Alright, so we're going to set them up so they match. Okay, so I've got my smaller one here and larger, smaller, larger. Alright, and we're going to set ourselves up a proportion. So I'm going to put up the top just for room's sake so I don't run over myself. Oops. I'm going to start here with the 50, the smaller one on the left. I'm going to go 50 over the small one on the right is equal to my large one on the left over my large one on the right. Okay, so you've got 2 options then. You can cross multiply. Okay, or you can just divide it in your calculator. So I'm just going to divide it in my calculator. So I've got 50 divided by 40, and I get, I've done something wrong there, 50 divided by 40, and I get 1.25 is equal to, and I do 65 divided by 52, and I get 1.25. So because I got the same answer, these are indeed similar by side angle side. Alright, so now I just need to come up with my similarity statement. HGF, okay, H over our longest side. Okay, so we started H on the other one because it matches up. So triangle H, we go past our longest side U, and then V. Alright, so we follow the same exact pattern. Our second one, we don't have any sides, so we're going to see if this is similar by angle. Alright, so I can see here I've got vertical angles I can add in the middle. So that's 1, but I've got 72 over here. Okay, now 72 doesn't match up with either of these. Right, now I could figure out the middle one, right, because triangles add to 180. Right, so I could work out that one, but if this doesn't add up to one of them, then the third one can't add up either. This one is not similar. Okay, there is not two angles there that are the same. Our last one, we don't have any angles, so we're going to try here for side, side, side. So again, I'm going to label these from smallest to largest. Okay, small, small, medium, medium, large, large. Okay, now I have to set up 3 proportions this time. So this time I will just be checking with my calculator. So I'm going to go small on small equals mid on mid, which is equal to large on large. 13 over 56. Now we want to check that all of them are the same. Okay, so you want to actually do them all in your calculator. 17 divided by 28, okay, we get 0.25 is equal to 11 divided by 44, again 0.25. And then we get 13 divided by 56, so we need to make sure it's 0.25 as well. We find it's actually 0.23, okay, so these are not similar, okay, because all 3 sets of sides are not similar. Okay, so if they turned out, it would have been okay, but in this case, not all 3 sides, so we can't use it. Alright, finally, end of our sheet. This time we're being given that things are similar, and we're going to set up proportions to solve for our missing side. So remember, our statements here are key. They tell us what matches up. So we can see our first 2 letters are RS. Okay, that means RS matches up with the first 2 letters of our other one, JK. Alright, so here we've got side, angle, side, but we've been told they're similar, so we're just going to use this to set our proportions up. So I'm going 56 over the top of 8 is equal to, and because I use this triangle first, I have to use this triangle, this side first again. We go 70 over our unknown, which I'm going to name X. Alright, so now we cross multiply. Alright, we put our band-aid on, and we get 56X is equal to, alright, and we get 560. Alright, then we just get X by itself, and we get X equals 10. Alright, now if we look at our numbers there, we think, does it make sense? Alright, so 56 was the smaller of the 2 sides, okay, 8's the smaller of 2 sides, it's a little bit bigger, okay, yeah, that sounds pretty good to me. Alright, 10 looks pretty good. Alright, so you got a couple more here to set up. Alright, remember in this one you've got your number statement again, but for the one in the middle you don't have your similarity statement. So just remember to just draw it out. Okay, draw your little one. 18, 20, and they share R. Alright, so R, F, G. And then draw your big one. R, Q, P. Right, then we can put our numbers on. So X, what we don't know, 50, what we do, and you've just turned it into a problem that we've already solved. Okay, so set up your proportions, cross multiply, and you'll be all good. All right, guys, I will see you next week.